Hello, hi everyone, welcome back to the channel. So today this video lecture we're going to be solving this problem, longest substring without repeating characters. So in this problem we're given a string, we have to find the length of longest substring without repeating characters. For instance, like here we have a string of length 8 and we want to find the longest substring in this given string which do not have any repeating character. Like first such valid substring would be this ABC has unique characters, it has a length of 3. Another can be this ABC which also has a length of 3, and that's all. These are the only substrings. Like we have one more here, CAB, it also has a length of 3. So we conclude that the length of the maximum length of the substring without repeating character is 3. So how do we calculate that length? Okay, so let's see that. To solve such kind of problems, like we know that, like here we have A, then I move to B, then I move to C, and then here I'm encountering A again. That means I must keep track of every character while I traverse the string, so that whenever I encounter a repeating character, I immediately get to know that it's a repeating character or it has been visited previously. So to do so, we use hashing technique. So since we know that this string, we can see that the string consists of English letters, digits and symbols as well as spaces. We take a array of size 258, okay, because this covers all of the ASCII values for all type of characters. So we use the array of this size, and in this array we simply count the frequency of every character while we are traversing the string. So let's say we have an array like this, A, B, C. So we have these 3 characters in this string. Now this array is initialized to 0. Now we start traversing this string from the very first character. So we count the frequency of A, it becomes 1. Then we count the frequency of B, it becomes 1. Then I count C. So here I see that when I encounter A, I see that A has been visited before because its frequency here is 1. That means I update my answer variable. So I keep an answer variable with 3 because initially this was initialized to 0, okay, and now it becomes 3 because since we are traversing this string, I am standing on this 4th character which is A and its index is 3. The length of the substring with non-repeating character would be 3. Fine. To do so, we also keep a left pointer. We'll see why we use left pointer. So since we are encountering this A, I will increment the frequency of A to be 2. It becomes 2. Now the left pointer stands at index number 0. I start moving my left pointer towards right until the frequency of this character becomes 1. Fine, because this is the first character which is repeating. So I will traverse this, I will move this pointer, the left pointer, towards right and keep decrementing the frequency of every character which I traverse using this left pointer. So initially left pointer points to this A. Now I move the left pointer towards right by 1 and this becomes 1. So this becomes 1 and the left pointer stands here at character number B. Now we see that the frequency of A, B, C is 111. That means I again have a valid window, fine, where the frequency of every character is 1, because here in the previous window I could see that the frequency of character A became 2. So I moved my left pointer towards right such that the frequency decreases to 1 for the character A. Now I again move my right pointer towards right. So my right pointer comes at this index, which is index number 4, and the frequency of B becomes 2. Now again, this is a repeating character because I encounter B again. It was already there in this hash map or in this array. That means I again have to move this left pointer towards right until the frequency of B becomes 1. So I move the left pointer towards right by 1 unit, and the frequency of character B becomes 1 again. Now I am standing on this window CAB. Its length is again 3. Now I move my right pointer towards right. It traverses this character C. The frequency of character C becomes 2. That means I'm again encountering a repeating character. Then I again move my left pointer towards right. Now it traverses this character A, which is there at index number 3, and the frequency of character C again becomes 1. That means I'm simply keeping a window. I'm keeping track of the frequency of every character in the current window, and when the frequency of every character in the current window is at most 1, then that means this is a valid window. There is no repeating character, and I'm gonna update my answer with that window like this: max of answer with these pointers. Let's call the right pointer to be j and left pointer to be I plus 1. This gives me the length of the current window or the current valid window. Fine. So in this fashion I traverse this string using these 2 pointers. So we can say that it's a 2-pointer approach or a sliding window approach with additional space, where we simply count the frequency of every character in the current window on which we are standing. Fine. So in this fashion we're going to be solving this problem. So let's jump to the code implementation part. Okay, so let's implement the solution. Let's create a vector of frequency vector of size 258, initialize it to 0. Okay, now create 2 variables: left initialize to 0, right initialize to 0, answer initialize to 0. Run the while loop until this right is less than n. So n is nothing but the length of the string s. Okay, then here you have to check if the check if the frequency for the character at the right position. So for the character which is at the right position, if it is non-zero, then that means we are revisiting this character, and in that case I will run this. I will update my answer first: max of answer right minus left. Then I will run this while loop. I will move my left pointer till this frequency for the current character is greater than 0. I will move my left pointer, and hence the frequency for the character at the left position also decreases. Frequency for L left decreases, left moves towards right, and that's all. Otherwise we are encountering this character the very first time, and we count its frequency here and move this right pointer towards right by 1 unit. Finally update this answer with answer of right minus left and return this answer right at the end of the function. Okay, so let's submit it. So it got accepted. So you can see that since we are traversing over the string exactly once over every character, the time complexity is big of n, which is the time complexity for 2-pointer approach, while the space complexity is constant because we are using constant memory of like we are using this array, we already have fixed size for this array, therefore the space used is also constant. Okay, so that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel and stay tuned with me for further updates. I'm gonna launch a new series very soon, so I hope to see you all in my next video.